Okay, this is the final exercises video to go over the last of the exercises for this course. The first section for the exercises was 7.1, section 1, and it was 2 through 20 even. Many of the answers are at the back of the book, but I'll go through the ones that are not. And so what you're supposed to do in each of these is you're to follow each of the following list of premises and derive the conclusion and supply the justification for it. There is only one possible answer for each problem. So this will give you some practice in doing a step of a logical proof. So for number 2, we have S, and then S implies M. The only conclusion you can reach is M by modus ponens. So answer for 2 is M by modus ponens. For number 6, we have not J or P as the first premise, not J is the second premise, and S implies J is the third premise. The only conclusion that you can draw from these premises is not S by modus tollens. Number 8, we have first premise, S implies W. Second premise is not S. And the third premise is S or N. The only thing we can conclude given those premises is N by disjunctive syllogism. So that would be 2 and 3, disjunctive syllogism. Number 12, we have first premise is K implies not R. The second premise is not R. Third premise is R or S. Fourth premise is R implies T. And what we can conclude from these premises is S by disjunctive syllogisms of lines 2 and 3. Number 14, its first premise is N implies not E. The second premise is not S, which in the rules of replacement, which we didn't do in here, but the rules of replacement, not S is equal to simply S. So double negation gets rid of both negations. Number 3, not E or not S. And premise number 4, not S or N. And if we look at this, the thing that we can conclude from this is N, because not S is the negation of not S. And so we have 2 and 4 disjunctive syllogism that allows us to conclude N. So that was the first part of those exercises. So we have 18 as well. We have the first premise, R implies M, and that all that implies D. Second premise is M implies C. And the third premise is D implies M or E. And the fourth premise is not M. So it may not be immediately clear what you can prove from all this, but if we look at the fact that R implies M implies D, and then we see D implies M or E, we can plug in the hypothetical syllogism rule of implication, and that would give us R implies M or E. So that would be 1 and 3 hypothetical syllogism. And the last one for this section is number 20. And the first premise was A or W implies N implies Q. Second premise was Q implies G. Third premise was not A. Fourth premise was Q implies G implies A or N. And what can we conclude from this? Well, we can conclude A or N by modus ponens of steps 4 and 2. So that's it for this section. Moving on to 7.1 section 2, the following symbolized arguments are missing a premise. Write the premise needed to drive the conclusion, the last line, and supply the justification for the conclusion. Try to construct the simplest premise needed to drive the conclusion. So again, this is another thing that will help you practice the skills needed to construct logical proofs. So let's do number 2. Its first premise is N implies S. Then we're missing a premise. and then the conclusion would be 3. So what would we need to be able to conclude S? Well, we would need N, and by modus ponens of 1 and 2, we could conclude S. Number 3, we have K implies T is the first premise. The second premise is missing, and we want to conclude, number 3, not K. So how can we get not K? Well, if we had not T and the second premise, then through modus tollens 1 and 2, we can conclude not K. So that's the answer for number 3. For number 5, first premise is F implies N. The second premise is N implies T. We have a missing premise, and then we're asked to conclude not F. And so not F, if we could get a not N, then by modus tollens on 1 and 3, we could conclude not F. So premise number 3 then would be not N, and by modus tollens steps 1 and 3, we would conclude not F. Number 6, we have first premise is W or T. The second is A implies W. And the conclusion, the next third premise is missing. And the fourth, what we're asked to prove is A implies T. So we have A implies W. And if we want to prove A implies T, if we had W implies T, then through hypothetical syllogism, we could prove A implies T. So that would be what would go into the missing premise. W implies T, and by hypothetical syllogism of steps 2 and 3, we could prove A implies T. Number 8, first premise was C or L. The second was L implies T, and we're asked to conclude L. If we had a not C, then through disjunctive syllogism, we could conclude L. So we just simply put a not C into that missing premise, and then we're able to conclude by disjunctive syllogism, steps 1 and 3, L. And the last one for this section is number 9. We have first premise is E implies N. Second is T or not E. And the third is S implies E. And we're asked to prove E. This one is a simple case of modus ponens. So if we have S at missing premise 4, then we can, from steps 3 and 4 and modus ponens, conclude E at step 5. So that's it for that section. So what we have now is in section 3, we have asked to prove certain conclusions. And so I'm going to go through the proofs for 3, 9, and 15. These exercises from chapter 7.1, section 3 of the exercises, I'm going to go through proofs number 3, 9, and 15. The other proofs are in the back of the book, or if you still need some help from some of the other ones, I'm happy to do that through email. But hopefully this will give you an idea of how to go about doing these proofs. So first off, let's do number 3 here. And so number 3, we have K and B, or L implies E. And then number 2, the second premise is K, not K and B. Third premise is not E, and we're asked to prove not C. So going back to the strategies, we have to say, is there a C in the premises? And there is a C. This was written more like a C, but that's a C. So we do have a C here. How can we get the C by itself? Well, this is part of a disjunction, and if we could get the negation of this side of the disjunction, then we can get this side by itself. And we actually have that in the premises. So we can immediately go to step number 4 and get C implies E by 1 and 2 disjunctive syllogism. And now we can immediately get to not C because we have a not E. And by modus tollens, this brings us to not C by 4-3 modus tollens. it doesn't really matter which order you put these numbers in, 1, 2, 2, 1, 4, 3, 3, 4, as long as you have the correct statements and they together correspond with the rule and the conclusion that comes from that rule. Okay, so let's go on to number 9. So number 9, the first premise is not G implies G or not A. Second premise is not A implies C implies A. And the third premise is not G. So again, we want to get not C as the conclusion. And so we have C here again. So again, C is part of an implication. So if we can use modus tollens again like we did in the last one, we would end up with not C. But in order to get the C implies A by itself, we need to end up with not A. But we have a not A here, but we have to kind of get it separated out of this statement. But we can begin to do that because we have a not G here, and by modus ponens, we can get this by itself. So let's start with that. G or not A by modus ponens 1 and 3. Now we also have a not G and a G or not A, and so by disjunctive syllogism we can end up with not A by itself. So that's 3 and 4 disjunctive syllogism. And this brings us to step 6, because now we can get C implies A by itself, because we now have the not A. And that gives us C implies A by modus ponens of 2 and 5. And now we can get not C by modus tollens by 5 and 6. And there we go, that's it. Now we'll move on and do number 15. Okay, now we're on to question or problem number 15 from chapter 7.1, exercises section 3, question number 15. So we're asked then with these premises to prove not D. And so as the first strategy has it, we're to look in the premises to see where there's a D, and we have a D here. And so as we've been seeing the last couple, this looks like it would be a good case for a modus tollens again. We can end up with a not A. And we have a not A here, and we also have not A as part of a disjunctive syllogism. So as we know with a disjunctive syllogism, if we have a not J, then we can conclude not A. And we do have a not J. So we can immediately go to not A by 2 and 3 disjunctive syllogism. And now we need to end up getting this all by itself. So let's use modus ponens to get this part by itself. We already have the not J, so we can get this by itself through modus ponens because we have the not J. We can therefore conclude the right side or the consequent of the modus ponens. And that gives us not A implies D implies A. And this is 1 and 3 modus ponens. And we can use modus ponens again because we have not A and we have not A to get D implies A by itself by 4 and 5 modus ponens. And modus tollens again will get us the not D by 4 and 6. And there we go. That's proof for number 15.
Moving on now to section 7.2. In this section we learned the other 4 rules of implication. And so these exercises are similar to the ones in 7.1. We just have more
rules of implication to work with. So let's go through the ones that are at the back of the book. Number 2 was, the first premise was N implies T and F implies Q. The second premise was N implies R or F implies M. And the third premise was N or F. So we're asked to prove what can be proven with these premises. And whenever you have a conjunction of implications like you have in step 1, and you have the N or F that you have in step 3, you can immediately use constructive dilemma to get T or Q. So step 4 is T or Q by 1 and 3 constructive dilemma. And actually, it actually tells you which rule to use in the exercises, so you don't have to guess which rule to use. You're being told to use it. Number 3. The first premise is D. The second premise is W. You're asked to use conjunction, and so the step 3, then you have D dot W, 1 and 2 conjunction. Number 5, you have R, N, or dot, N or K, first premise. Second premise is G and T or S. Third premise is Q and C or J and L. And so you're asked to use simplification. You can only use simplification in a conjunction, but it has to be a conjunction where the terms are truly distinct from one another. You can't use it, for example, in premise 2, where the conjunction is within a larger statement. So it's only in step 1 where you have the dot conjoining 2 separate statements. And so there you can separate the R out from step 1 by simplification. So the conclusion is R by step 1 simplification. Number 6, we have the first premise is not R or P. Second premise is P implies not D, conjoined with not R implies S. The third is not R implies A, and P implies not N. And the fourth premise is left blank, but we're asked to use constructive dilemma. And so we do have not R or P is in the first step, and then we have in the third step not R implies A and P implies N. So through constructive dilemma we get A or not N by steps 1 and 3. Number 8, we have step 1 is E and G. We're asked to use addition, so we could do E and G within parentheses and then wedge whatever we want to add to that. Pick a letter as long as it's not E or G. And finally, number 9, we have first premise is not B, second premise is F or N, and we're asked to use conjunction. And so conjunction, we would end up with not B and, in parentheses, F or N, steps 1 and 2 conjunction. So that's it for the first section of the exercises in 7.2. Now for exercises in section 3 of 7.2. Again, we have proofs, but these proofs now will draw from all 8 of the rules of implication that we've had so far. So I'm going to do 14, 18, and 20, and that will be it for the exercises. Now we're in section 7.2, section 3, problem number 14. So this proof, we're asked to prove not H and not T. And so the question then is, do we have not H and not T anywhere in the proof? Well, we do have H and T here, and we have a T there. Whenever you have a conjunction like this, one strategy is to try to get the not H and not T by themselves, and then you can just conjoin them through conjunction. So that would probably be the strategy to try to go with. So let's try that. So first off, let's see if we can get the not T by itself. And we have F and O here, and with modus ponens we can get this part by itself. But first we need to get F by itself, and we can simplify here just f by 3 simplification, right? It's only with a conjunction that you can just simply take it out. Like if Jeff is a Californian and Jeff is a philosopher, you can just say Jeff is a Californian. So that's how you can work this out. So now we have a modus ponens that we can do, and we can conclude not T and A by 1 and 4 modus ponens. And now we can get the not T by itself through simplification from 5. And now we need to work on the not H. And so if we had a not T or G, then by modus ponens again, we could get that half of the implication by itself. And then we could use modus tollens, right, to get the not H. So we have the not T right here. There's no G anywhere, but we can use addition to add it. So we'll do that as 6 addition. And that leaves us with H implies T by modus ponens of 2 and 7. And then we can finally get to not H by modus tollens of 8 and 6. And then that leaves us then with not H and not T by conjunction of 9 and 6. All right, that's it for number 14. Now we'll go on to number 18. Okay, now we move on to problem 18, and these are our premises, and we're asked to prove R or F. And this is always a good one to think about, constructive dilemma, unless you could end up with R all by itself and then an F all by itself. But now even there you can't just add it, so constructive dilemma looks like it's the way to go here. So constructive dilemma, if you look at the rule, it's the hardest one to remember. You need to have, we have a not T or E. So if we had a not T implies R and an E implies F, then we could conclude R or F. So do we have a not T implies R? We do. So we can end up with that by itself. And do we have an E implies F? We do. So we can end up with these two by themselves, then we add them together by conjunction, and then with line number 3, we can then by constructive dilemma conclude that. So let's, looks like we should be able to go about doing that. So let's go. So we have not H and D, so we can get not H by itself by simplification from line 4. And that allows us then in step 6 to get not T implies R by modus ponens of 1 and 5. And we have not H, and we have H or E implies F. So by disjunctive syllogism, right, we can get E implies F by itself. So E implies F by steps 2 and 5, disjunctive syllogism. And so that gives us, we can now add T implies R, not T implies R, and, oops, and E implies F by 6 and 7 conjunction. And now that leads us with constructive dilemma 8 and 3. We can conclude R or F. So that's 8, 3 constructive dilemma. All right, you can replay that one if that'll help you to understand that, but that's a good example of using the constructive dilemma rule of implication for proof. And now we'll go on to the last one, number 20. Now we move on to number 20. With this one, we're asked again to prove disjunction. So that's another opportunity where it might be wise to think about constructive dilemma. So if we can end up with, for instance, if we could end up with D implies B, and F implies G, and D or F, just looking at what we have here in the premises, then we could definitely do V or G by constructive dilemma, because this is basically the rule of constructive dilemma. It has different letters, but it's basically the same form. And that's the key thing to remember, right? It's the form that matters. Actual letters that are in the place doesn't matter as much as the form in which it takes place. So we have D or F as one of the premises already. So can we get D and B and F and G? So we'd have F and G here. So we would need to get M or N in order to prove that. We don't have N anywhere other than right there. So why don't we do this? Get M by 4 simplification. And then we can, by simply addition, add N to M. And so that's 6 addition. And now we can use modus ponens to get F implies G by 1 and 7 modus ponens. And now we can add F implies G and D implies B together. Do we have D implies B? No, it's not. C implies B. Well, I thought we had D or F. Oh, yes, we can. We can get D implies B by hypothetical syllogism. I knew it was there. So D implies not C implies B. So we can get D implies B by hypothetical syllogism 2 and 3. As you see, sometimes you have to look for a minute, think about it for a minute before it clicks, and you can see, okay, this is how I go about doing it. And now we add F, which D implies B, and F implies G by 8 and 9 addition. And that leads us to step number 11. We can prove B or G by constructive dilemma of 10 and 5. Constructive dilemma. So that was one of the harder proofs, but you can see each step follows by one of the rules that we've learned in this section.
Now that step 10 is not addition but conjunction of F implies B and F implies G, or D implies B and F implies G. So it's conjunction, not addition. But that's it for the exercises, and that's it for all the material for this course. Good luck on the quiz.